Hello, everyone. Thank you all for joining us for Phius Alliance Southwest's spring meeting. My name is Alyssa Fink, and I'm the president of the board of the Southwest chapter. If you hadn't had the chance to join us before, welcome again. As a chapter of the Phius Alliance, our mission is to provide a community for the growing number of passive building professionals in the Southwest region of the US, including Arizona, Colorado, New Mexico, and Utah. In just a moment, my fellow board member, Sophie Martin, is going to introduce Cody Belton, who is our guest speaker for this meeting. After his presentation, we'll have a few minutes of questions. I'll talk a bit about two very exciting in-person passive building events coming to our region this year, and then we'll wrap up by one so you can get on with your day. And just as a reminder, today's presentation also provides one Phius CEU and one AIA credit, so be sure to stick around to the end for those. And without further ado, Sophie, please take it away.
Yeah, sure. So I will be introducing Cody, my colleague here at Stantec. He is a certified passive house consultant with Phius, alongside numerous other certifications and designations. And he is a building enclosure consultant in our building sciences team at Stantec and our passive house lead for North America. So I will let Cody add to that introduction if I've left anything out. And thanks for being here and providing this presentation for us today.
Oh, happy to be joining all of you. Thanks for having me. Thank you for the invite. We do have a lot of content to cover, so I will get right to the presentation. So hopefully this is sharing properly. Can you all see that title page there?
Yes.
Perfect. All right. Well, welcome everyone. Thank you for the kind introduction, Sophie. I think you pretty much covered it all. I guess the one thing I would add, just for those who have never heard of Akira Window Connection, I am the inventor of this window install method. I didn't do it alone though. Back in 2023, I applied for a grant from the British Columbia government for BC Housing. They used to do these grants that would basically fund up to $30,000 for anything in the realm of building innovation or education. And I had this idea to create essentially a thermal bridge-free window install or for a window or door install. And once we received that funding, that really helped kickstart our Stantec team to basically vet this idea both through structural analysis and thermal analysis, when that is 3D thermal analysis to give the most accurate linear transmittance results and analyze it from a condensation risk potential lens to see if it really is what we want it to be. So we'll dive right in. So what we're going to be going over is what Akira Window Connection is. We're going to review some past water penetration results. I'm going to review a case study that we do similar case studies with a lot of ongoing projects just to try to determine what detailing we want to use on particular projects. And we're going to get into talk about other projects that have integrated Akira Window Connection. So this ranges from passive house projects that are pursuing the top levels of energy performance with BC's. So I'm based in British Columbia, Canada. The BC Energy Step Code. So there's some buildings that are trying to hit the top levels of that. So we've used Akira Window Connection on those. And there's also projects that have integrated it in prefabricated wall panels. So there's a huge range of applications for this. And that particular project is the VIU student housing project. So that's Vancouver Island University. And we're going to review some mock-up testing and lessons learned. And I have some updated photographs of how that project is progressing. So what is Akira Window Connection? Akira Window Connection is a dead load support system with intermittent brackets fastened to the backup wall structure and a horizontal girt supported by those brackets. So the system has sufficient structural capacity to support large windows, enabling architects to exercise design freedom. And the continuous angle is decoupled from the backup wall to reduce heat transfer and simplify air and moisture barrier detailing. So this connection method can provide nearly thermal bridge-free linear transmittance values, or psi values, at the window-to-wall transitions to help improve whole building thermal energy performance at both new developments or deep energy retrofits. So to review some of the sequencing, so there's a lot of different backup wall options that Akira Window Connection could be applied to. Essentially, it would be a good strategy for any wall that uses exterior or external wall insulation as a primary thermal barrier. So this is just an example of a steel stud backup wall. So here we have 16 gauge steel studs spaced at 16 inches on center at the windowsill. You'll have your conventional exterior wall sheathing, so it could be dense glass or something like that. There's an option to line the rough opening with plywood. So this is common practice where I come from. It help with applying different membranes to the sill and whatnot to give you a smoother workable surface rather than dealing with the steel studs. And part of the wind load support system, it's very typical for us to use continuous metal angles at the sill that's fastened into the window frame to help pick up that wind load. And mind you, these are screenshots taken from our 3D thermal modeling software, so this particular sequence doesn't include the wall membranes, but I'll get to that in a later slide. So before you put on these brackets, you're gonna wrap your walls with your wall membranes and pre-strip your windows. But what's going to pick up the weight, the vertical loads or dead loads of your window system, it's no longer going to be supported on its typical position on the sill. We are going to use or repurpose cladding attachment brackets. So in this case, these are approximately 3 inches in depth here. And we're going to line the top edge with a 2-inch by 2-inch. And in this case that we analyzed is an 18 gauge steel, galvanized steel angle. So this creates this gap between the exterior wall sheathing and this horizontal angle. So that allows your exterior insulation to butt directly into your fenestration with minimal interruption to reduce that thermal bridging. So this horizontal angle becomes the new bearing point. So window manufacturers like to use intermittent shims to help level their window systems. So we're going to do the same here. So in this particular model, we're showing Universal Series fiberglass frame window by Cascadia Windows. So in a past research study, we repurposed some old thermal modeling detailing, and we already had this window in place. So that's what we chose to use for this study. And then you're going to have your field of the wall installation for how your cladding is being attached. So in this case, they're using larger intermittent brackets with horizontal girts. And you're going to want to fill that space between the intermittent shims with some sort of insulation. So I believe good building science practice calls for something that allows for some free draining. So I like to use loose fill mineral wool to fill in those voids. And then you install your exterior insulation layers that's going to butt into your window frame. And in this particular case, we slightly over-insulated the frame edge. That's absolutely not a mandatory thing with Akira Window Connection, but the point of this particular detail is we wanted to try to drive down this linear transmittance or thermal bridge as low as possible. So we wanted to do everything in our power to make this thermal bridge free. And what we found with some trial and error is if you line the interior rough opening with 1-inch rigid insulation, so in this case this was XPS, we found some reductions in our thermal bridging as well. And then in our steel stud cavities, we have bad insulation, and you apply your interior finishes, and that's it. That is Akira Window Connection in a nutshell. So this is another view of it from the underside, just so you can get an idea of how we're trying to expose the bottom edge of that window frame so we can get our exterior insulation to butt into it. And then when you look at our thermal modeling, so these are the isotherms representing the different temperatures as we move from the warm interior surface identified with red lines to the colder exterior with blue, and how the heat transfers through our wall assembly and our window assembly. So ideally what we're trying to avoid is major jogs in our isotherms with our connection details. If we can get these isotherms to flow relatively smoothly from one junction to the next, we can really lower our heat loss at that particular junction. So you can imagine if we did the more conventional approach where we previously used to use a lot of steel angles to support windowsills and door sills, you would see a massive jog with this green line that more or less represents the center of the wall assembly and glazing assembly. So this is a major improvement where the heat loss is avoided in this situation. So now to look at the water resistant barriers, or the WRB, and the air barrier detailing. So this more or less aligns with conventional best practice that's been used for decades from my experience. So you install the WRB sheathing membrane pre-stripping on the exterior wall, and you wrap into the window's rough opening over the plywood liner at the sill, at the head and jambs, and recommend using self-adhered membrane for this application that can self-seal at fastener penetrations, and to use prefabricated corner pieces, membrane gussets, and sealant as necessary to be air and water tight. So at the sill, if a continuous sill angle is installed as part of the Windows wind load support system, as previously mentioned, that's on top of that plywood liner, then the WRB should wrap up and over that sill angle to form a waterproof back dam. So if you refer to location A on the left here, I'm going to try to zoom in. So in this detail, we provided an air and water seal installed between the interior edge of the window frame and the sub-sill flashing membrane. So this could be with an air barrier tape or sealant. So the other beauty of this particular install that I like from a building science perspective is that window systems, if we aren't proactively, renewing them after the end of their service life, they will eventually leak. This typically might happen at the mitered corners where, different windows are manufactured in different ways, but a lot of the times they will rely on some sort of internal sealants. And at these mitered corners where they're relying on sealants, those eventually will fail and you'll get water percolating through your window frame. So I like the idea of positioning the window completely outboard of our WRB, where the water can basically freely drain through our exterior insulation layers, if it is something that's more or less breathable, like semi-rigid mineral wool. So to get into the window head install sequencing, so we again have the steel stud backup wall, our exterior wall sheathing, we're lining it with plywood, and our clear field wall assembly, whatever that may be. And the only difference here is that at the head, we don't need to worry about the vertical loads of the fenestration. So all you're seeing here is the intermittent strap anchors that the window manufacturer will use. And this window positioning will work for pretty much all window manufacturers, where the strap anchor should still be able to reach the backup wall to fasten into that. And then again, we wanted to really try to reduce the heat loss at the window head location, so we again over-insulated the frame. We aligned the interior rough opening with that 1-inch XPS insulation, filled the stud cavities with the bad insulation, got our interior finishes there. And again, you could see a nice smooth transition of our isotherms from our window system to our opaque wall system above. So at the head and jambs, if additional moisture durability is desired, you can install a self-adhered membrane or a high-performance tape on the sheathing membrane pre-stripping at the wall face and seal to the window frame. And if you look at location F on the left here, so this provides an air and water air seal installed between the WRB sheathing membrane pre-stripping and the window frame from the interior side. So again, this could be an air barrier tape or rod and caulk seal. And in a later slide, we'll get into some laboratory testing done at Cascadia Windows, where basically we would test this at absolute worst case scenario that wouldn't really happen in a real situation, but to really test the durability of these types of rod and caulk seals at the perimeter, we tested the window with having the entire WRB exposed. So there was no exterior insulation, there was no cladding. We just had the WRB installed on the wall, the window installed, sealed with rod and caulk, and tested it mimicking a high wind-driven rain event and had successful results with no leakage. So here are some sample data results sheets available at thermalenvelope.ca for Akira Window Connection for the steel stud backup wall option. So this is, if you've never heard of thermalenvelope.ca, I highly recommend you go check it out after this presentation. It is, I believe, North America's greatest resource for learning about the U values of opaque wall assemblies and roof assemblies, all floor assemblies, and the psi values modeled in 3D at various junction details. So it's, I believe, over 700 plus details and growing. And these were added a ways back. And as more manufacturers adopt Akira Window Connection, we will be adding more and more options, analyzing different products and their respective psi values or linear transmittance values. And here's the data and result sheet for Akira Window Connection with a CLT, a mass timber backup wall option. And for this backup wall, the window to wall transitions at the head, sill, and jamb are considered thermal bridge free because the linear transmittant values are less than 0.01 watts per meter Kelvin. But in the Phius world, what you consider a thermal bridge free threshold would be values less than 0.006 BTUs per foot per hour Fahrenheit. So the use of intermittent brackets, this triggers the need to use 3D thermal simulations to get accurate psi value results and accurate interior surface temperatures. So attempting to use 2D thermal modeling methods such as using Therm or Flixo, although they all have their place for certain situations, but as soon as you're starting to deal with more lateral heat flows created by highly conductive components like metal thermal brackets, and especially when you're dealing with steel studs, it's the 2D models can't accurately capture the heat loss that are happening laterally because we only can slice through one plane of that particular junction. So this is where relying on 3D thermal simulations is a big help to get more accurate information into your thermal model. And yeah, because potentially if you're relying on 2D results, your results could be skewed plus or minus potentially 60% we found in the past. So yeah, if it's a high impact thermal bridge, it's really important to get very accurate results. So the facade team at Stantec conducted a detailed structural analysis of Akira Window Connection with IsoClips as the window dead load support system. So in the various scenarios examined, the system demonstrated structural competence and accommodating considerably tall maximum window heights, making this system a structurally viable choice for numerous projects across Canada and the US. So table 3 at the bottom here shows the maximum intermittent bracket spacing required to support various window heights. So a 12 pound per square foot triple glazed window. So this is assuming worst case scenario with 6 millimeter glass per pane. So that's a 25-foot. So in this number that's highlighted here, so it's measured in inches, but so this equates to a 25-foot tall window that could be supported by brackets spaced at 16 inches on center when attached to 16 gauge steel stud framing. And the window height limitations would not be from Akira Window Connection, is what we learned in this initial review. Commonly, the window manufacturing itself limits the window size. So this just goes to show the, you know, that Akira Window Connection is increasing the design freedom for these architects that may want to have larger windows, because the risk of using a window install method that hasn't been vetted by structural analysis is that the architect may want to have large windows on a particular project, but if your energy modeling assumed a system that, there are many different methods out there. The ones that come to mind right now are, the type of systems that use rigid foam in some cases fastened to your backup wall to help support the windows. This might work on, single family homes, smaller windows potentially, maybe when combustibility isn't a concern. But on larger projects with larger windows, you really want to have this analyzed, hopefully up front with some design assist, because if it's considered later in design, at the construction stage, there might be some hard lessons learned if you were relying on a thermal bridge free detail and find out later that it's not constructible for the certain application you're trying to insert it into, and then that could be a huge space heating demand penalty you might have to face later if you have to increase that linear transmittance. So the building performance analysis team at Stantec conducted a thermal analysis of Akira Window Connection with a 3¼ inch ISO clip as the window dead load support system. So the thermal analysis was for a steel stud backup wall that included R19 bat insulation in the steel stud cavities, and they tested various exterior mineral wool insulation thicknesses that are listed here at 4 inches thick, 6 inches, and 8 inches. So I know these results here are very small, but you will receive a copy of this presentation so you can check them out later or request them from Northern Facades or Rainiers, which were the components analyzed in this system. But these are the results, and yeah, and they provide the results for all the different insulation levels for the different transitions at the head, sill, and jamb. So the facade team also conducted a detailed structural analysis for another thermal bracket, Cascadia clips, as the window dead load support system in this case. So here I got some sequencing using this particular product. So with every cladding bracket, thermal bracket you may want to use for your particular project, they all have different pros and cons and features. One unique thing about this particular product is that I visited their manufacturing plant in Langley, and these brackets can actually be cut to customize sizes, so the actual height of these things can be adjusted to potentially support even larger windows. So that was a unique factor of this. And to suit the manufacturer's wants for this particular install, we actually, instead of having the interior face of the window frame exactly aligned with the exterior face of the exterior wall sheathing, they wanted it to be slightly inset so they can still utilize their strap anchors that are typically installed at the head and jambs for wind load resistance. So it's the exact same concept. We're lining it with our horizontal girt, Got their window there. And yeah, you've seen all that before. So to give you some insight into their structure results, so table 3 here shows the maximum intermittent bracket spacing required to support these various window heights. So this is for 16 and 18 gauge steel stud walls and a 6-inch thick concrete wall. So again, analyzing the worst case scenario using a 12-pound per square foot triple glazed window. So we could support a 17-foot tall window when the brackets are spaced at 16 inches on center when attached to 16 gauge steel stud framing. And if your projects have punch windows using Cascadia's Universal Series windows that are taller than 11 feet, you would likely need to contact Cascadia Windows to help assist with the overall window design because there could be special considerations when you're getting into windows at that height. So the building performance analysis team at Stantec also conducted a thermal and condensation analysis of Akira Window Connection with the 3-inch Cascadia clips as the window dead load support system. So for this analysis, it was again for the steel stud backup wall that included R19 bad insulation and the same amount of insulation varieties previously presented with the ISO clip option. So this is for the 4-inch, 6-inch, and 8-inch exterior insulation options. And again, here's some very small results for you to review at a later date, I hope. But yeah, this gives you some data, accurate data inputs you could be using on your energy models for window installs at the head, jamb, and sill. So the condensation risk analysis, this focused on the window to wall connection detail and evaluates surface temperature at the glazing, window frame, and window support components. So this analysis is based on conservative estimates for steady state conditions to determine if the condensation would accumulate when interior air contacts components within the connection detail. So the Akira Window Connection thermal simulation calculated no risk of condensation at all component surfaces inboard of the exterior gypsum wallboard that are warmer than the interior air dew point temperature, with the interior air temperature at 68 degrees Fahrenheit with 60% relative humidity. Now, Cascadia constructed a laboratory mock-up with a Universal Series fixed window supported by Akira Window Connection with their 3-inch Cascadia clips. So the air and water seal at the sill was achieved with sealant, and so there's a sealant bead at the interior edge of the window frame and the sub-sill flashing membrane on the sill angle. At the head and jambs, rod and caulk was installed in between the WRB sheathing membrane and pre-stripping at the window frame from the interior side to maintain air barrier continuity and provide watertight joints. So this is nothing new. This is very conventional practice that I've been basically seeing and doing on majority of our projects going back to 2006. So I'm sure it goes much further back than that. And this is a very tried, tested, and true method of creating good air tightness, continuity, and water tightness between your wall and your window system. So here's a little video of the testing chamber installed at the Cascadia Windows factory in Langley, British Columbia. So they do a lot of these testing when they're manufacturing their windows, and they want to make sure that they have a high level of quality control. So I'm not sure at what frequency they do this, but yeah, this was a handy little chamber to conduct this test for this unique, innovative window install. So now we have Akira Window Connection dead load structure results. We have linear transmittance results for various backup wall types. And now we really need to put this to the test on a real project. So we started by conducting a thermal performance study for the Twin Towers retrofit project using Akira Window Connection at all punch windows to showcase its beneficial impact to the external wall design. So a little background information on this project. The Twin Towers are two concrete, mixed-use, high-rise towers located in North Vancouver, British Columbia. They were constructed in 1977. So Tower A is 16 stories, Tower B is 13 stories, and the retrofit is targeting Step 3 in the BC Energy Step Code, which has a space heating demand target of 25 kilowatt hours per meter squared per year. So to achieve Step 3, so based on the project's dynamic energy model, we need an opaque wall system that meets or exceeds effective R 9.1. So how do we get there? What wall assembly and window install design will achieve this thermal resistance target? So we analyzed 3 different window install design options, and all 3 are available to view at thermalenvelope.ca. We have the conventional option on the left, the improved option in the middle, and Akira Window Connection shown on the right. So the objective was to determine the clear field wall design based on the 3 window installs shown here, and how a better window install design can provide a trade-off opportunity with the external walls to reduce the exterior insulation thickness. So all 3 options will produce equivalent energy performance and provide an impact to the wall construction material costs. So first we analyzed a poor window install, so the conventional option, where the window's sitting directly in the rough opening on the steel studs. So this option leads us to add excessive insulation to the external walls to compensate for the heat loss born from this window to wall transition. So this can be explored in the energy model, but typically reveal diminishing returns to the overall thermal performance. So by taking this path, we're adding insulation material to lower operational carbon while increasing embodied carbon with all this extra material. So for the Twin Towers, to achieve effective R 9.1 for the above grade walls, this would require 10 inches of exterior mineral wool insulation to compensate for the conventional window install's heat loss. So a more effective energy conservation approach is to reduce heat loss at high impact thermal bridges that can be optimized. So by changing the window install to Akira Window Connection, we can reduce the exterior walls insulation to 6 inches thick in lieu of 10 inches and still achieve effective R 9.1 at external walls. So table 8 shows the material cost comparison for Akira Window Connection plus exterior wall impacts for the Twin Towers retrofit. So in essence, with this reduction in insulation from the exterior insulation and the reduction in cladding attachment brackets, we would anticipate to save up to $454,000 Canadian, or about $331,000 US in material costs compared to a scenario with a conventional window installation. Now getting into some projects that we've used or are using Akira Window Connection in. So we have the Peony Amphitheater project in Vancouver. So the back of house, behind the stage where we have dressing rooms, there's a commercial kitchen downstairs. So this building originally was targeting passive house, but because of adding the commercial kitchen in the basement and the relatively small size of this back of house, achieving passive house wasn't feasible. So we ended up targeting the CA-GBC zero carbon building design standard instead. So detail 4 on the left side shows Akira Window Connection at a concrete wall, and detail 3 and 6 on the right side shows Akira Window Connection at a steel stud backup wall. And the tallest window on this project is 15 feet tall. So based on our previous detailed structural analysis using 3-inch Cascadia clip, this window falls within the structural capacity of Akira Window Connection. And here are some recent photos of the project with Akira Window Connection complete at this one location. And here's an interior view, just to show some of the conventional air and moisture barrier detailing at the jamb and sill using rod and caulk. Now here we have the Connaught Triplex and Character House. So this project is pursuing Passive House Classic certification for the Triplex and the Enerfit Classic certification for the Character House on the same site. So although technically challenging due to the small scale, the design team and ownership collaborated extensively on this project, and it's been pretty rewarding up until this point. They just broke ground a couple weeks ago, and we are on track for our final design that is on track for Passive House Classic certification for this triplex building. So here are some of the Akira Window Connection details in practice. So the top left details Akira Window Connection supporting a window. So this is at the top of an insulated concrete form wall. And the bottom left is Akira Window Connection supporting a sliding glass door at the ground floor slab on grade. And the right side is a swing door at the ground floor slab on grade. On to the VIU student housing project, so Vancouver Island University. So this project is targeting a 15 kilowatt hour per meter squared per year TEDI or space heating demand. So that's getting very close to Passive House Classic energy performance levels. So this project will use a prefabricated wall panel by Centura Building Systems. So standard window detailing used early in the early design iterations resulted in effective R24.5 walls, but based on the project's dynamic energy model, this wasn't good enough to meet step 4 TEDI for this project. So changing the window install to use Akira Window Connection raised the wall's effective R value to R29.2, and that was necessary to achieve the TEDI target without adding additional exterior mineral wool insulation to the walls that was already 8 inches thick. So part of this project's quality control plan is to build a prefabricated wall panel mock-up at the Centura Building Systems facility that includes one window installed using Akira Window Connection. So the wall's primary air barrier is a self-adhered membrane installed over the exterior gypsum wallboard with primer, and they use 3M ultra conformable flashing tape at all the corners at the window. And the completed off-site mock-up can be seen in the bottom right photo there. So these photos were taken on the interior side of the mock-up. So if you refer to the bottom right photo, the air and water seal at the sill was achieved with a sealant bead installed in between the interior edge of the window frame and the subsill flashing membrane on the sill angle back dam. And at the head and jambs, the rod and caulk was installed in between the self-adhered air and moisture barrier sheathing membrane pre-stripping and window frame from the interior side to maintain air barrier continuity and provide watertight transitions. And you may have noticed that there's a big black smudge going over the strap anchors. So initially in this mock-up, the installers smeared sealant from the rod and caulk over these anchors, attempting to seal them up, but this is not the recommended approach. And this may have passed the water penetration testing, likely because we have lots of redundancy and protection with the exterior cladding and exterior insulation. But when we tested it with qualitative air leakage testing, it definitely picked up these air leaks. And so the next step was for Centura Building Systems to repair these sealant joints to have the mock-up tested again for air leakage. So the lesson learned here was proper sealant application. So one, you need to execute proper surface preparation. And for these particular strap anchors, so these windows are from Cascadia Windows, and Cascadia Windows does have a nice sealant bead tutorial video on their website. So here are a couple screen grabs from that tutorial. essentially is an easy protocol to make sure that you have sealant at the interface between your intermittent strap anchors and your air barrier and water barrier membranes. And another little tip and trick is to install black backer rod with a contrasting sealant color, because this really helps with a visual quality control check, because you notice in the previous slides they use black rod and caulk, so visually it'd be very hard to see if at the midpoint, if the sealant's very thin, because you wouldn't even notice that you could actually see the backer rod. So if you were to use a clear or white sealant, you would have better quality control. So this is probably getting a little in the weeds, but definitely with different sealants, there's different protocols in terms of your maximum joint width, how much it can move, and setting your mid-span depth for that sealant. So that all comes in with proper workmanship and tooling of your joints. Here are some recent photos of this project with the prefabricated wall panels being installed. And finally, key takeaways for Akira Window Connection. So it's optimized to decrease your window thermal bridging heat loss. Akira Window Connection allows you to align your window frame and walls exterior insulation. The water-resistant barrier and air barrier detailing aligns with conventional best practices using rod and caulk joints. Energy conservation savings could be used to create an alternate wall design with reduced exterior insulation. This could lead to decrease in wall thickness, increased cladding attachment options with smaller brackets, decrease in embodied carbon emissions. So this means less insulation, less raw material extracted, processed, manufactured, transported, installed, and disposed of at the end of the building service life, and decrease wall construction costs due to the reduced exterior wall insulation and reduced cladding bracket sizes. So this install is suitable for non-combustible construction and combustible construction for both new developments or deep energy retrofits. And that's it. Hopefully we got some time for some questions before the Phius announcements.
Yeah, thanks, Cody. I see a couple of questions in the chat. I think they were pretty early in the presentation, so generally have been covered, but the two questions are, how is the window frame drained? No, you went into that a bit. And how is the window fastened? Brackets, direct window screws, flange. Again, you went into that a bit, but anything that you think would be helpful to add?
So likely you wouldn't use your typical nail-on flange windows for this particular install, because we're positioning the windows completely outboard of your backup wall structure. You're not going to have anything to nail to, and that's kind of the point. And I'm sure some people have been involved with projects where they create a window buck. They'll line the outside of their sheathing around their windows and doors with 2x material, or something else, maybe a compact foam or something. But for this to really reduce the heat loss, we want to maximize our exterior wall insulation completely butting into the perimeter edges of our fenestration to reduce that heat loss. So by using a rebate style, so basically any windows that I'm aware of, like particular PVC windows and whatnot that have a nail-on flange, those could be snapped off, or you can ask your manufacturer to snap them off for you, and they become rebate style windows. So that is more or less the style of window you would use with Akira Window Connection. And yeah, if you want me to elaborate more on the subsill drainage method, I can go into more detail with that if you'd like.
Yeah, thanks for that. I have one question, but is anyone else on the call have a question or want to jump in? We have a few minutes here, so we'll give the floor to our attendees. I see one question that says, in the middle is a operable window, and on the left, a fixed window with less frame sash overall. Is there a test showing fixed in the middle as well?
Sorry, can you repeat the question?
Oh, this is a direct message to. Looks like it may have just come to me by DM somehow. Oh, I see. Tim is forwarding a message that came to him in a direct message. So this Stephen must be referring to a picture that you must have been showing at some point.
Yeah, it sounds. I could probably bring up that particular slide. Just one second here. Quickly, this slide.
Yeah, is this the slide? Is Steve and Stefan want to weigh in? He was the person that asked the question.
Somehow, when I write an chat direct message, it always goes to Tim. So I have no idea. So that's why I have to follow. The question was, in the middle, there is an operable window, like a tilted turn window, tested, and on the right side, there's only a fixed frame. So is that, does it have any influence because you have more sash and frame on the middle than on the right side with the good results?
Yeah, you're absolutely right. Like there are, this isn't a complete apples to apples comparison. Like all three of these assemblies have slightly different wall types. Like the one on the left has less exterior insulation. It's a metal framed window. And the one on the right is a fiberglass window. The the problem we have right now in the industry is a lack of open source thermal bridge detailing. So when you're in the early design stages of a project, typically there's not a budget to do a bunch of thermal analysis. So you have to work with what you have. So this is somewhat the process that we go through when we're analyzing, placeholder values for your psi values for your window to wall transitions is what values do we have available to us. So when you go to thermalenvelope.ca, although it has hundreds of details, when it comes to something that's a steel stud backup wall and you're looking for psi values for your window install, these are the options you have. And I'm hoping over time, as say, if window manufacturers like the idea of recommending this type of window install to show off their windows in the best light possible with, a very good window install, then we'll have more and more data and comparable analysis of, comparing the variations, the different window frames, the operable versus the fixed. So you're absolutely right. It has some influence. I couldn't tell you how big of an influence, but this is a real world example of using the data that we have because, that's what we do on real projects. And yeah, at the later stages when details start to get more refined, we know you know, what the window frame is actually going to be, then some budget is allocated to actually get that modeling done. But in the early stages, when there's so many variables you don't know, we need a good placeholder value for these thermal bridges. Um, to make sure that we're trying to be as accurate as possible as early as possible. So, yeah, hopefully that helps.
Yeah, I was just wondering because we went last year to the Phius and we showed an installation, especially for European tilt and turn window. with a method that it over isolates the window frame and gives the perfect, like I said, thermal bridge free installation with over isolating the window frame to get the isothermic line out of the rough opening. So that's why I was a little bit confused that you compared here a fixed glazing with an operable tilt and turn window. But yeah, the answer is good. Thank you.
Yeah, and Phius looks at this differently than the Passive House Institute. So Phius has default values you can use for your window install transitions. I have a feeling that may change in the future. Like I've had some conversations with some people at Phius, and it's um the rules of thumb of, just having your window position mid-wall and you're able to use certain psi values. I think probably for smaller buildings, that's probably fine because you have less length of window to wall transitions on smaller buildings. But when you get into larger buildings, multifamily residential buildings where you could have miles of sills, jams, and heads, and if you're not utilizing an accurate psi value, it could
Yeah.
completely throw your model off. So, it's accepted right now to use default values according to Phius, but I believe in time, um, yeah, I think there's going to be more finite rules with that in terms of the size of the project that's applicable to, because
Yeah,
yeah,
we are here in Germany. We have the approach to do PHI and Phius. So we are based in Germany and use PHI and Phius, and the mixture, I would say, is the goal. And we're doing multifamily passive house buildings in the US, and yeah, it's a good presentation. It's really interesting.
thank you.
Nice. Thank you both. Good to have some good conversation on that piece. And then I'm going to turn it over to Alyssa for the last 6 or so minutes for some chapter updates. So thank you, Cody, and thank you everyone for those questions.
Yes,
Thank
thank
you.
you so much, Cody. Thank you for moderating some Q&A there, Sophie. And Cody, if people have questions, that last slide had an email that they can contact you with. Is that correct?
Yep, absolutely.
Okay, great. Thank you. And would you mind putting that in the chat now as well while I'm talking, just so we can make sure that people have that?
Sure thing.
Thank you. So we'll wrap up the meeting with a few updates, and then I'll share that self-report code for the Phius CEUs and a form that you can use to report your AIA number for AIA credits. And let me share my screen. So first of all, a few chapter updates. Coming up later this year, we have PhiusCon, which is the largest annual passive building conference in North America that's coming to our region, to Phoenix, Arizona this fall. Please save the date, October 8th through the 10th. There are usually hundreds of passive building enthusiasts from around the world that attend each year, so lots of people to meet and lots to learn. We hope to see you there. Second, recently announced, on the road to PhiusCon this year, Phius will be hosting a brand new one-day event in Tucson on May 29th called Phius Foundations Live, Passive Building in the Southwest. Now, it's designed for the Phius curious, and it introduces topics like building physics, mechanical systems, and the Phius certification process within the context of specifically Southern Arizona's climate and industry conditions. And then attendees will be able to complete the self-guided passive building foundations training for just $100, which is usually $450, to earn the Phius Associate designation. So if you're just getting started on your passive building journey, or you know someone else who is just getting started, we'd love to see you there, or for you to pass along the recommendation to check this event out. And finally, we always have things going on as a chapter. And we'd love for you to get involved by telling us about the events that you would like to see us put together, sharing content for our newsletter, like projects that you're working on right now, and getting involved in your state level committee to help organize local meetups and in-person events. And our Colorado committee is starting to get pretty active, chaired by Sophie Martin. Sophie, can you talk about that for a little bit?
Yeah, sure. If you are located in Colorado, doing work in Colorado, and are interested in engaging in our state level committee, let me know. Whether you are interested in potentially being a part of our smaller group committee members that are going to be planning events and networking, or if you just want to be on the listserv, so you can get that email about when we're having events. We'll have some in person, we'll have some virtual. Going to do our best to try to make it as accessible as we can for our Colorado folks. So just let me know if you're interested.